Okay, ladies and gentlemen, today we are going to solve and factor quadratic equations of the form ax squared plus bx plus c. So basically the difference between the last couple days and today is that there's going to be a number in front of the x squared. And this is just going to make us have to do one extra little step. All right, so let's think back to how we factored a problem that looked like this. We want to first check to see if there's a GCF. Is there a number I can divide everything by? There's not. So option 2 is to group, factor by grouping. So the first two numbers can be divided by a common factor of x. So I get x, 5x plus 2. And the second two numbers can be divided by 5. So I get plus 5, 5x plus 2. And remember, the goal is that whatever's in parentheses is exactly the same. So you smash together the GCFs and write one of the numbers that's in the parentheses. And that's our factored version. So I want you to think about how this is the same as this. Is it equivalent? You betcha. All we've done is split 27x into 2x and 25x. Now, why 2x and 25x? We're going to get to that in just a second. So in order to factor something that has a number in front of the x squared, what you have to do is, obviously we can't divide by a GCF, we can't do grouping yet, but what we can do is make a factor and sum table. Now, we're still finding sums of 27, that middle number, but we're finding factors of 5 times 10, which is 50. So I'm looking for factors of 50 that add up to 27. 2 times 25 adds up to 27, and that's where the 2 and the 25 come from. So let's do a complete example. All right, I'm going to start with this one down here. I'm worried I might run out of space on the top one. So we're looking at 2x squared plus 14x plus 20. So the first thing we do is we take the first number and the last number and we multiply them together. That gives me 40. So I'm looking for factors of 40 that add up to 14. So what you'll notice is our factors side is going to start getting bigger. We're using bigger numbers, so it's going to get a bit more complicated there. So factors of 40, I got 1 times 40, 2 times 20, 3 is not going to work, 4 times 10, ooh, that adds up to 14. So once I figure out the pair that works, I split. I don't immediately write x plus 4, x plus 10. That won't work because x times x is not 2x squared. So we can't do that. What we do is we split the middle term into a 4x and a 10x. You can write that in either order because 10 plus 4 and 4 plus 10 is still 14. We continue writing the plus 20 and we continue writing the 2x squared. Okay? So because 4x is positive, we put the plus sign. That's how we get all of our parts there. Okay, now that I have this equivalent statement, I can factor by grouping. The first two numbers can be divided by 2x, and that gives me 2x, x plus 2. And the last two numbers can be divided by 10. And that gives me x plus 2. So remember, our goal is to get the thing in the parentheses equivalent so that we can smash together the outside. And now we have a factored version. That is the factored version of 2x squared plus 4x plus 20. Let's try another one so that you guys can see that you're getting the hang of this. 3x squared plus 7x minus 5. So remember, the very first thing I need to do is multiply the first term and the last term. 3 times negative 5. That gives me negative 15. So I'm looking for factors of negative 15 that add up to 7. Okay, so let's start thinking about some numbers that'll work here. I could do 1 times 15. I could do 3 times 5. Looking like we don't have any factors here. One of them has to be negative, and it should be the smaller one. Neither of those things add up to 7, so guess what? This is what we call, oops, I wrote the letter wrong. This is what we call a prime factorization. This cannot be factored. It is what it is. Remember when you have a number like 13, it's prime because it can only be 1 times 13. That's the same idea. There aren't any factors, so it's prime. All right, sorry to trick you there a little bit. Let's try another one then. Let's do this first one here. 4x squared plus 24x plus 32. So again, we take the first two numbers and we multiply them. And 4 times 32 is 128. So we are looking for factors of 128 that add up to 24. So I already know that 4 times 32 multiplies to 128, but it does not add to 24. Another option would be 8 times 16, and 8 plus 16 is 24. So remember, after we find our set of factors, we're going to split the middle term into those two pieces. And we continue writing the rest of the problem, because it has to be equivalent to the previous piece. All right, so now that we've split it, we can factor by grouping. So we can group these two together, divide by 4x, group these two together, divide by 16. And so that'll give me 4x on the outside, x plus 2 on the inside, plus 16 x plus 2 on the inside. Again, we've got the same thing written inside the parentheses, so we can smash the outsides together. So my final answer is 4x plus 16 times x plus 2. Now, I just realized a mistake, and you're going to kind of like this mistake. So look back to this original problem. Before we even start factoring something, the very first thing we have to ask ourselves is there a GCF? This problem had a GCF. Do you know what the GCF is? What can you divide all three of those by? You can divide them all by 4, okay? So let's make a little space over here. Rewrite the problem. I've got 4x squared plus 24x plus 32. I'm going to divide everything by 4. So I put a 4 on the outside. That gives me x squared plus 6x plus 8. This is going to give me a different answer. It's going to be equivalent, but it's going to be the more simplified version. Okay, so that 4 goes on the outside. And I'm looking for factors of 8 that add up to 6. And 2 times 4 is going to do that for me. So x plus 2, x plus 4. Now the reason I noticed this is because when I got to the end here, I noticed that that had a common factor. Okay, so this technically is the best answer, the most simplified answer. All right, so we've worked some on factoring. Let's go on to solving. If we think about solving, remember solving is just taking it one extra step after factoring it. Remember, it has to be an equation, and the equation must be equal to 0. So that's always your first step, is to make it equal to 0. Then we want to try to factor it. Do we have a GCF? No. Okay, so that means we're going to have to try to find factors of 3 times 35, which is going to be 105. Factors of 105 that add up to 26. Okay, so let's start thinking. We could do 3 times 35, but that does not add up to 26. What about 5? 5 times 21. That adds up to 26. Okay, so remember the next step is to separate that middle term into those two numbers. So we're going to write 3x squared plus 5x plus 21x plus 35 equals 0. Now we factor by grouping. I'm going to divide by an x, and I'm going to divide by a 7. So that gives me x, 3x plus 5 plus 7, 3x plus 5 equals 0. These two things are the exact same thing, so we can smash together the outside. X plus 7, 3x plus 5 equals 0. And now we can apply the zero product property because I have something times something equals 0. So either x plus 7 equals 0 or 3x plus 5 equals 0. Solve these real quick. Subtract 7 from both sides. X equals -7, or subtract 5 from both sides. 3x equals -5. Divide by 3. X equals -5/3. So my two possible answers are -7 and -5/3. So hopefully you're getting the hang of this, and let's see if you can do a little bit of homework on it. We're going to do the odd problems, and remember there can be some prime. Remember the difference between factoring and solving. This part about confirming your answers, we're not doing that. Okay, so good luck, have a great time.